This is a very important reasoning question for exam. Although phenoxide ion is more number of resonating structure than carboxylate ion, carboxylic acid is a stronger acid on phenol. Why? You studied about phenol, its acidity in the chapter alcohol, phenol and ether in term 1 examination. Let me tell you, we studied in alcohol chapter phenol is more acidic in nature. Why? You know, this is called phenol. Phenol, when it leaves this hydrogen as H plus ion, you will get the compound, right? This is the one we are getting O minus. This H is going as H plus, so you will get O minus. This is called what? Phenoxide ion, right? Phenoxide ion. You know, phenoxide ion is highly stable due to resonance. I will just draw one of two resonance structure. You know, oxygen having lone pair. What happened? This lone pair shifted. You will get the resonating structure like this. This is studied in the term 1 classes, right? So this is a negative charge lone pair. So like that, total 5 resonating structures are there. So dear all, in all the other resonating structure, in the next resonance structure, you will get the negative charge on this carbon and next one negative charge here. That is the respective structures you will get it. All of you just check the phenoxide ion resonance stability. Now let me take a carboxylate ion. What is carboxylate ion? So let me take carboxylic acid. What is carboxylic acid? Benzene with the COOH, carboxylic acid. You know, this hydrogen is acidic in nature, so it can leave it as H plus ion. When this hydrogen is leaving as H plus ion, this oxygen carry a negative charge. So I can write benzene with C double bond O minus. You know, a double bonded oxygen, C double bonded oxygen carrying 2 lone pair. Why? Because this oxygen 2 bond is there. 2 bond is equal to 4 electron. To complete its octet, 2 more lone pair. This is a single bonded oxygen, only 1 bond. 1 bond is equal to 2 electrons. So remaining total there will be 3 lone pair. This is the compound called carboxylate ion. Okay, carboxylate ion. So this is phenol on losing hydrogen, phenoxide ion, carboxylic acid on losing hydrogen, carboxylate ion. So both are acidic in nature because they donated H plus ion. Now, let me draw one of the resonance structure of this compound. Dear all of you, carboxylic acid is an electron withdrawing group. So the electron movement is like this. Okay, they will take electron from the ring. So you will get the structure like this. This is the compound. Where is the positive charge? Here, because from this carbon, electron loss. Okay, here also you will get 5 resonating structure. Which is more stable? That's my question. Whether phenoxide ion or carboxylate ion, which is more stabilized? Let me tell you, this is more stable. This is more stable. Its resonating structures are more stable, dear student, compared to phenoxide ion. Why? In this compound, you can see where is the negative charge located. See, in this resonating structure here, carbon carry a positive charge. Both of the negative charge is on oxygen. You know, oxygen is a highly electronegative element. It prefers negative charge. It is highly stable. What about the resonating structure of phenoxide ion? Here the carbon carry negative charge. Carbon carry negative charge. Carbon and oxygen, when you consider who is the most electronegative element? Oxygen. So he prefer negative charge. This is the more stable structure. So we can say the resonating structures of carboxylate ions are more stable than phenoxide ion. So these structures are more stable mean this carboxylic acid is ready to lose the hydrogen, right? Because when the carboxylic acid lose that hydrogen, the forming compound is more stable. So they are ready to lose the hydrogen because they are therefore they are more stable. So carboxylic acids are more stable than phenol. Okay, next one. Write the structure of the product. Simple. This is benzene. This is ethyl CO group, right? Propanoyl chloride. You know, Na benzene treated with the acid chloride with the anhydrous AlCl3. What is this? Friedel-Crafts acylation. Friedel-Crafts acylation. Which is the acyl group? This is the acyl group. Chlorine is minus. This electrophile will go to the benzene ring. We will get benzene with CO. Benzene with the CO, C2H5. Benzene with the CO, C2H5. Write the structure only. Second reaction is very important, very important, very important. What is this? Benzene with the methyl group, nitro group. Okay. What is CrO2Cl2? Very important question, dear students. CrO2 is called what? CrO2Cl2, chromyl chloride. Chromyl chloride you studied in one of the naming reaction. That's called Itard reaction. What is the purpose of Itard reaction you studied before? It is the process of conversion of toluene to benzaldehyde. Which is the toluene part? Benzene with the CH3 is called toluene. It is converted to benzaldehyde. What is benzaldehyde? Benzene with CHO. Nitro group will be there without any change. So study the purpose of each and every reagents. Okay, CrO2Cl2 is called chromyl chloride. It is used in Itard reaction. During Itard reaction, benzaldehyde is converted into which one? Toluene is converted to which one? Benzaldehyde. Okay, so I made CH3 into CHO, no change for NO2. Next one. C6H5CH2CD. I'm just rewriting C6H5CH2 means benzyl dibenzyl cadmium with the 2CH3 COCl. Alright. You may study this reaction in the preparation of ketone. Your product is a ketone. Why? When a dialkyl cadmium you treated with the acid chloride, what happened? A very simple reaction, dear student. Cadmium, which included only one reaction we are dealing in this chapter. You please remove this cadmium and chlorine. Okay, it is removed as CdCl2. 2 chlorine, right? Cadmium dichloride. CdCl2 removed. Remaining group you just together. What is left side? You have C6H5CH2. Alright. No need to write twice. Okay. While balancing, it will become there. C6H. This is the group C6H5CH2. Now where it is connecting? This is the remaining part here. COCH3. COCH3. Okay, then you think this is twice, right? Yeah, this is twice, this is also twice. So we can write the product is twice. A dialkyl cadmium, when you reacted with the acid chloride, you studied, just check the notebook, the preparation of ketone from acid chloride. Acid chloride when treated with a dialkyl cadmium, cadmium dichloride will eliminated and remaining the alkyl part, you just join together. Okay, this one, and there twice. And here this is important reaction, dear student. This is what? CH3, C triple bond CH. What is this compound? Propyne. Propyne when treated with the mercury. This is a very tricky question. Mercury is the sulfuric acid. Dear all, here actually the reagent is not given. It's a very important one. This is a alkyne. This is mercury and H2SO4. Mercury. If they given mercury with a alkyne, the reaction is nothing but addition of water. Careful, okay? If they given a mercury with a alkyne, the addition of water is the reaction. You know, water contain 2 ions. What are they? H plus and OH minus. When you adding a positive and negative part to a unsymmetrical alkene or alkyne, you have to follow Markovnikov's rule, right? So let me follow what is the Markovnikov's product. According to Markovnikov's rule, you know, negative part will go to carbon with a very less number of hydrogen and here more hydrogen. So the product will be CH3, COH, double bond, CH2. Dear student, this compound is called a enol because it contains one alkene and alcohol, enol. It will undergo one of the isomerism you may studied before. That's called what? Tautomerism. Tautomerism. What is tautomerism? If the single carbon contain double bond and OH group, from the OH group, the hydrogen transferred to the CH2 group. The hydrogen reached here. So product is CH3. Okay, CH3. C. This O becomes double bond, alright? Double bond O. Double bond becomes single bond to the CH2. The hydrogen reached CH3. What is the compound here, all of you? Propanone or acetone. Propanone or acetone is the product. Okay, very careful. A alkyne with a mercury, if they given, they won't specify the water in the question. Please consider. Okay, water is the adding species. First follow Marconico's rule, then tautomerism. Then arrange the following compound in the increasing order of their boiling point. NCERT question, all of you. Here your starting material is, here I think this is a aldehyde, right? This is an aldehyde. This is a alcohol, all right? And what is this? CH3OCH3, it's an ether. And this is a alkane, means normal hydrocarbon. What is the question? Arrange the following in the increasing order of their boiling point. Boiling point. Dear all of you, please note the boiling point order of this functional group. You know, alcohols are greater. Alcohols having greater boiling point than aldehyde. Aldehyde having greater boiling point than ether. Ether having greater boiling point than hydrocarbon. Okay, you know alcohols, why it's having greater boiling point? Because alcohol have an ability to make very strong hydrogen bonding. The alcohol, aldehyde, ether, hydrocarbon is the increasing order of their boiling point. As per that, hope you can write the boiling point. Next one. Arrange the following. Most expected question for exam. Arrange the following carbonyl compound in the increasing order of their reactivity in nucleophilic addition. We discussed in the first part of the topic already. Nucleophilic addition reaction favor in aldehydes more than which one? Ketone. So the first aldehyde is which one? Ethanol, CH3CHO. Second one is propanol, CH3CH2CHO. Next one is propanone. Propanone is a ketone, right? It's a ketone. And last one is butanone. Okay, butanone. Dear student, keep in mind aldehydes are more reactive than ketone towards nucleophilic addition. What is here? A nucleophile is waiting with a negative charge. Where this nucleophile can add on the carbonyl group. You know this carbonyl carbon, I told you this is a carbon with a positive and negative charge because of their electronegativity. This is the carbon with a positive and negative charge. It's carbon with a positive, negative charge. Carbon with a positive, oxygen with a negative charge. Nucleophile can attack on the carbon with a greater positive charge. Dear student, here we have in this aldehyde only one alkyl group is there, electron donating group. Electron donating group, if it is there, it will decrease the positive charge on carbon, so nucleophile cannot attack fast. But here methyl and ethyl, when you consider electron donating power is greater for ethyl, right? So what happened? Its reactivity very less. What about ketone? Ketone left and right side both are giving donating groups, electrons. So therefore, in aldehyde you can see only one side alkyl group, but in ketone you can see the both side alkyl group. Therefore, I told you aldehydes are more reactive than ketone towards nucleophilic addition. Among these two aldehyde, who is more reactive? Let me take number 1, number 2, number 3, number 4. Among these two aldehyde, which is more reactive? First one, dear student, because first one contain less donating group. This is the point. Electron donating group will decrease the reactivity. This is a less donating, it's a more donating group. So it is having greater this reactivity. Then 1, 2. Among 3 and 4, which is little more reactive. This is 2 methyl group, this is 1 methyl and ethyl group. Here is the effect more, very less reactivity. So fourth one, then third one. This is the reactivity order of nucleophilic addition reaction for the aldehyde and ketone. Same question, benzaldehyde. What is benzaldehyde? Benzene with the CHO group. Para-tolualdehyde. What is para-tolualdehyde? Aldehyde is there, para position toluene, means benzene with the CH3 is called toluene, benzene with the CHO is called benzaldehyde, together is called para-tolualdehyde. Para-nitrobenzaldehyde. Benzaldehyde, para position nitro group. And acetophenone. What is acetophenone? Benzene with the COCH3. Let me take it. This is number 1, number 2, number 3, number 4. Dear student, the first 3 compounds all are aldehydes. First 3 compounds are aldehyde, last one is a ketone. We know aldehydes are more reactive than ketone, so I can place it. The ketone is the least reactive. So fourth one is least. Which is the most reactive aldehyde? Dear all, alkyl groups are electron donating group. We already said electron donating group will decrease the reactivity. Nitro group is a electron withdrawing group. He will increase the reactivity. So please note it all of you. Electron donating group will decrease the reactivity of aldehydes and ketone towards nucleophilic addition. Electron withdrawing group can increase the reactivity. So third compound having greatest reactivity. After that, first one and the second one. Because second one contain a donating group, right? When you consider 1, 2, 3, why third one greater? Because they are having withdrawing group. Then why first and second you consider first one greater? Because they doesn't contain a donating group. Because donating group, if it is there, it will decrease the reactivity. So second one lesser, then first, then 3, least one is 4 because it's a ketone. Then predict the product of the following. This set of reaction we can write it very simple manner, dear all of you. Very simple to write the product in this kind of questions. All of you check it, all of you. Very simple manner. All products are in a similar way. This is a cyclopentanone with the NH2OH. What is NH2OH is called? Hydroxylamine. Hydroxylamine. This aldehyde or ketone take the oxygen and this hydrogen, remove water, please club it. You have cyclopentane, double bond, this oxygen and hydrogen you eliminated, so you connect here, okay, NOH. From where you remove those points, you have to connect it. You know, a aldehyde or ketone when treated with a hydroxylamine, the product is known as oxime. The product is called what? Oxime. So careful. The aldehyde or ketone when they given, take the oxygen and take the hydrogen, remove water and NOH, you connect there. What is this compound, dear student? This is carbon number 1, 2, 3, 4. 2,4-dinitrophenylhydrazine we studied before. This is called 2,4-DNP. 2,4-DNP, right? 2,4-DNP. Okay, 2,4-DNP. 2,4-DNP test is given by both aldehyde and ketone. So here also you have to do the same procedure. Take this oxygen, take this H2, remove water, club the remaining compound. Here cyclohexane, double bond, N, remaining N, NH, the phenyl ring, nitro group, finish. 2,4-dinitrophenylhydrazine, when you reacted, the product is called what? 2,4-dinitrophenylhydrazone, right? Hydrazone. What about here? Same thing. I'm just rewriting this compound, RCH, double bond, CH, CHO group. Let me write it as CHO like this, okay? CHO. Plus, what is this compound, dear student? Semicarbazide. See, they will give you a tricky manner, this question. NH2CO, NH2 is called semicarbazide. We just discussed before in a reasoning question. In semicarbazide, there are two NH2 group. But which NH2 group we can mix with aldehyde or ketone? The NH2 group which is away from the CO group. This one. Okay, because this is involved in resonance, please don't take it. So I'm just writing the opposite way. NH2, NHCO, NH2. What you have to do? Same procedure. Take the oxygen, take this hydrogen, remove water and club it. You will get R, CH, double bond CH, then CH, here nitrogen, then NH, CO, NH2. When the aldehyde or ketone treated with a semicarbazide, the product is called what? Semicarbazone. What about the last one? Here same thing. Take this oxygen, take this NH. This is a simple amine. Whatever the NH2 group is there, just takes oxygen and NH2 and club them. So benzene. Here we have C. The C already contain one CH3 group. Then the double bond. Double bond is here, right? N. And you have CH2, CH3. So when a aldehyde or ketone treated with these kind of agents, don't try to do any other reaction, just eliminate water, write it. But be careful, when you treated any aldehyde or ketone with a hydroxylamine, the product is called what? Oxime. With the 2,4-DNP is called 2,4-dinitrophenylhydrazone. With the semicarbazide is called what? Semicarbazone. General name is enough. Okay. Then, which of the following acid expected to be the stronger acid? Dear all, we already discussed before, acidity mainly depends on two factors. One is electron donating group, one is the presence of withdrawing group. Who can increase the acidity? Electron withdrawing group can increase the acidity. Electron donating group will decrease the acidity. Come to the point. Here CH3COOH and CH3COOH, then here CH2 with a fluorine and COOH. Which is more reactive? Which is more acidic? This is ethanoic acid, this is 2-fluoroethanoic acid. This is only the difference, fluorine is there. Dear student, fluorine is a withdrawing group. If there is a withdrawing group, it will increase the acidity. So we can say the second one is more acidic. Next one, CH2 fluorine, okay, CH2 fluorine and COOH. Here CH2 chlorine and COOH. Here one is fluorine, one is chlorine. Fluorine is a withdrawing group, chlorine is also withdrawing group. But which is the strongest withdrawing group? You know, fluorine. So his effect is greater, he is the more acidic one. What about here? CH2F, CH2, CH2, COOH. The other one is CH3, CHF, CH2, COOH. In this case, you can able to understand both cases fluorine are there. Both are withdrawing group, right? Even same group. But how can we predict the acidity? In this first compound, the acid and fluorine is far away, so its effect is lesser. But here fluorine and acid is very closer, so electron withdrawing power is greater, right? So electron withdrawing group increase acidity, so he is more acidic. Then, last question all of you, carefully listen. There is one question we discussed, only one nomenclature or one naming reaction we discussed in the carboxylic acid part. That is called HVZ reaction, right? What is called HVZ reaction? What is HVZ? Hell-Volhard-Zelinsky reaction, right? Hell-Volhard-Zelinsky reaction. What is in this reaction is happening actually? Let me take a general equation. See a common example, let me take it, ethanoic acid. First, the acid. What is the condition in order to undergo HVZ reaction? Dear student, HVZ reaction, the condition is the reacting carboxylic acid. The reacting carboxylic acid must contain at least one alpha hydrogen. The reacting carboxylic acid must contain at least one alpha hydrogen. Is it contain alpha hydrogen? Yes, right? This is the major group, major functional group directly connected carbon is called alpha carbon. Alpha carbon contain hydrogens are called alpha hydrogen. Yeah, it having the alpha hydrogen, it can undergo the reaction. What is the reaction? First, we are adding halogen. Halogens chlorine in presence of red phosphorus catalyst. Here, any halogens we cannot add it. The halogens can be either chlorine or bromine. Okay, any one of them. Second step, hydrolysis. Add water. Process is very simple. From your carboxylic acid, remove one alpha hydrogen, add one halogen. So CH2, Cl, COOH. This is the reaction. What is that? From your alpha carbon, remove one alpha hydrogen, add your chlorine, either chlorine or bromine. Yeah, that is the reaction. So you will get, you know, this is the alpha carbon, right? So it's called alpha chloro, because alpha carbon contain one chlorine. Alpha chloro benzoic acid, will get it, benzoic acid. What is the name of this acid? This is ethanoic acid, right? This is called what? Ethanoic acid. Ethanoic acid. What is the name of this one? This is 2-chloroethanoic acid. 2-chloroethanoic acid. So this is called our HVZ reaction. A carboxylic acid, if it contain a alpha hydrogen, you can remove the one alpha hydrogen, add one chlorine or bromine. That's it. Here the question, propanoic acid. Okay, let me take your starting material, propanoic acid, CH3, CH2, COOH. We have to convert into 2-chloropropanoic acid. Dear student, this is the second carbon, right, in which one chlorine is required. Yeah, this is the acid group. So this is the alpha carbon from which one hydrogen we want to remove and add one chlorine. That's it, right? That is HVZ reaction. Okay, so let us add halogen in presence of red phosphorus. Secondly, we are adding water. So what happened? CH3 from alpha hydrogen, one of the alpha hydrogen you remove and add your halogen. Yes, this is our product called 2-chloropropanoic acid, right? 1, 2, 3, 2-chloropropanoic acid. Okay, this HVZ reaction, careful, it is not given by the acids. HVZ reaction on an acid, okay? Acid should contain alpha hydrogen. Here acid, those acids which doesn't contain alpha hydrogen, it won't give the reaction. For example, HCOOH. Methanoic acid. Yes, student, it having no alpha hydrogen, so no alpha carbon, no alpha hydrogen, right? It cannot give the test. HVZ reaction. Hell, Volhard, Zelinsky. Another one, benzoic acid. See, benzene with acid, benzoic acid. This is the alpha carbon. That alpha carbon, no alpha hydrogen. So these methanoic acid, benzoic acid, those kind of carboxylic acids cannot give HVZ reaction. Clear, all of you? So dear all, this is our most important. Okay, most important chapter in your chemistry, part 2 exam, part 2 the paper means your textbook. Even in chemistry, all subject in grade 12, this is the one of the most important chapter and lengthy chapter. You know, as per the pandemic, they didn't deleted any of the topic, even one topic they didn't deleted from the chapter Aldehydes, Ketones and Carboxylic acid, which means it's an important weightage chapter. So the parts of these chapters are aldehyde, ketones and carboxylic acids. To study all of you the entire topics, even naming reaction, distinguishing test, IUPAC nomenclature, physical and chemical, every property of these functional group, aldehyde, ketone and carboxylic acid. Hope you clear each and every question based on the chapter aldehydes, ketones and carboxylic acid. All of you prepare well for your examination. We will meet again with a lot of other chapter and their important question. See you in the next video. Till then, bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.